So good day guys, I am Alferos from EC31 and I am here to present my final project in Digital Electronics 2, wherein I will create a project that demonstrate an actual application of servo motor and PIC microcontroller. So for that, I have conceptualized to make an animal barrier. So to start, let's go to File, New Project, Standalone project. Next, and let's find our device, the PIC 16F18875. There we go. Next, and our compiler. Next, and let's just name this as SA4 and finish. Then click Tools, Embedded, and our code configurator. Select MCC Classic and then click Finish. We can now change our package to PDIP40 to get the microchip that we wanted, and on the device resources, let us locate on the timer and let's add TMR2. And also on the PWM, let us add PWM6. Then going back to the pin manager grid view, let us just enable the port A, specifically on the GPIO output, the first one and the second one as well. And also on the switching part, I have set this as port C on the fourth one input, and for the PWM, that is just on the port D, wherein I'll just, let's say, at 0, and there you go. And let's just check if is it alright. Yes, enable timer to 50% active high on the TMR2. Enable timer, roll over pulse over control. Let's just change this to frequency oscillator over 4, and the prescaler, instead of 1:1, change it to 1:64, and have our timer period to, let's say, 20 ms. On the interrupt part, just check it, and on the system module part, just check it. HVNT OSC 4 MHz 4 enabled, and on the pin module, we can just change this. Let's say this is LED _1. This one is LED _2. Since this is switch, you can say this is SW. Just uncheck the analog. While checking the WPU in the GPIO switch. After everything else, we can now click Generate. After generation, we can now proceed to the projects. Locate our main C file. Just click that, SA4, as well as the PWM6 file located on the generated files. There, PWM6. Now there is a pre-type code that I have made, the combination of main C file and PWM6 C file. So on here, specifically on line 74, the PWM6 _ load duty value, we're just going to copy it and insert it on some parts of the main C file. So here on the main C file, I have inserted uint16 _ t duty cycle, and inside the while loop, if SW or the switch get value is equal to 0, equals 0, so LED _1 will be set high, and it follows that for duty cycle is equal to 90, then duty cycle is greater than 10, duty cycle minus minus. So that's the code for it. And for the delay, I have set it to the 3000 millisecond delay or 3 seconds, wherein this is the one that I am telling the PWM6 underscore load duty value. This was extracted from here. So just copy this and paste it here. And for the next 4, duty cycle is less than or equal to 10, and then duty cycle is now greater to 90 and duty cycle plus plus. It follows that the delay ms is at 3000 again, 3000 milliseconds or 3 seconds. And just like here, I just copy this and paste it over here. PWM6 underscore load duty value and duty cycle. Else, if on the other side, LED underscore 2 underscore set high will be initiated and returned, and the cycle goes on. So now that I have constructed my main C file codes, I can now click this and build. And before proceeding to the MPLAB X IPE, I set up the connection in my laptop wherein the PIC was connected together with the IC. So the connection goes as the first one, VPP, will go to pin 1 of the IC. The second one, VDD, will go to pin 11. The third one, VSS, will go to pin 12. The fourth one, ICSP data, will go to pin 40. And the fifth one, ICSP clock, will go to pin 39. And now we can go to MPLAB X IPE after connecting it first. Now that we are on the MPLAB X IPE, we can now connect our device. Just click OK. And since there is a notification that the target device was not found again, just like from the previous experiments, just go to Settings and Advanced Mode and type the microchip as the default password. Here on Advanced Mode, let us proceed to power, change the voltage level from 5.0 to 3.125, and just check the power target circuit from PIC3. And on the operate side, we can browse our hex file, and this is our hex file. Let's just open, and after the hex file was loaded successfully, we can now program it. Just click OK. There you go, programming complete, and now we can proceed to our hardware. And finally, after taking so long, sorry for that since I have modified my codes. I have problems, errors, loose connections, but I still successfully made it and troubleshooted it. So to explain my circuit, I have supplied it with a 5 volts DC. This is the positive supply, negative supply, and the third pin goes to the color green LED with a 220 ohms resistor, while the fourth pin goes to the red LED with a 220 ohms resistor too. For the 11th and 32nd pins, that goes to the positive since those are the VDDs, and the 12th and 31st pins goes to the negative since those are the VSS. On the 23rd slot, that is where I put my switch that is also connected to a ground attack switch, this one. And for the connection of the servo motor, this one, orange one indicates the connection going to the 19th pin, while the black one will go directly to the negative terminal or the ground, while the red one will go directly to the positive. And then I guess that's it. I used the PIC 16. I really thought that there is a problem over here, but just loose connections upon configuring it on my laptop, so beware of that. And for here, I have a model of an improvised wherein I use a popsicle stick as an alternative animal barrier, since that is my goal, to make an animal barrier. And here I have miniatures, so I don't have a real animal, just a toy for demonstration purposes only. So the concept goes like, when I turn this on or I switch this, the red color LED will light up. So it means that it is like on an idle mode or not yet being pressed here in the switch. So when this switch, tap switch, is being pressed even once, color green will light up, and that indicates the entry of animals using this barrier. And by the use of the servo motor, it will rise up to a certain degree and go down again. Maybe my mistake is that I made it so fast. That is why it's just like a span of couple of seconds, 3 seconds, something like that. It will easily go down, but I have realized that it would be much better if it will take another press before it goes down, because animals take time in order to pass the barrier. So to try this, there you go. I have inserted my power supply. There, the LED color red indicates that it's not yet being pressed or idle. So once I press this, animals can now cross it. The only thing is I have not configured it slower, but still the concept is there. So let's try again for another one. Animals will cross, and this is a fence-like barrier. So again, to appreciate this, there you go. And for the last time, there you go. So that's it, my final project in Digital Electronics 2. I have made an animal barrier. I hope you like it and you have learned something. Thank you for watching, and goodbye.